So we're working on problems where you're mixing together two different things the same thing that's got different concentrations, and we're trying to get a desired result. And you start using words like that, concentrations and mixtures and systems of equations, and it gets pretty spooky. So let me see if I can clarify here what we're looking at. So you've got a company here that mixes cleaning agents for groups that help recover from floods. A crew needs 80 gallons of bleach that's 14% chlorine. So you got some amount that you need over here, and it's 80 gallons worth of mixture. Okay, and like if this is the water level up here, here's the level right there. Only a certain percentage of it is chlorine. If you can imagine putting all the chlorine down at the bottom. The whole thing is 80 gallons, and there's a certain amount down here, 14%, that's all chlorine. But here's the problem: we don't have 80 gallons of 14% chlorine. All we've got is some that's 8% and some that's 40%. So we're going to mix them together, but we can't just throw a bit of each in there and hope we get the right mixture. We need to get the exact right amount so that we get 14% chlorine. So here's where we're going to go with this. I'm going to imagine mixing one batch over here that's got 8% chlorine, okay, and another batch over here that's got 40% chlorine, okay, and I'm going to hope that when it's all said and done, I get 80 gallons with the right amount of chlorine. Okay, so here's the deal. I think what I'm going to do, just to get us started, is take a guess. Let's just guess that it's, say, 50 and 30. Okay, well, that wasn't hard to get 80 gallons. That wasn't very difficult. We just added 50 and 30. Here's the question: do we have enough chlorine in there? Well, here's the problem. First is, I don't know how much chlorine's in here, and I don't know how much chlorine's in here, and I don't even know how much chlorine I need. Well, I actually do know how much chlorine I need. I need 14% of that. Okay, so let's first step over here to the side and figure out what 14% of 80 is. Okay, and to do that, you'll do 0.14 times 80. Okay, so let's get with that. Okay, I used a calculator, and I got 11.2 gallons of chlorine. Okay, so I've got a total of 80 gallons here, and 11.2 gallons of it is chlorine. Okay, well, let's figure out if we guess the right amount. We need to find out what 8% of 50 is and 40% of 30, and add those together to see how much chlorine we've got. Okay, so 8% of 50 is how much chlorine is in the first mixture. 40% of 30 is how much is in the second one. So 8% of 50, okay, that's 4. Okay, and 40% of 30, that is 12. Okay, so if we add those two together, I get 16. Well, I was supposed to get 11.2, so apparently I guessed wrong. Well, let's just guess again. What if I guess, let's see here, how about 30 and 50? Okay, that still adds together to get 80. Okay, but I don't know if I've got the right amount of chlorine. But here's the deal. I'm still going to calculate the amount of chlorine the same way. I'm just going to multiply by 30 here instead of 50. Okay, and I'm going to get 2.4 here. And I'm still going to multiply, I'm going to find 40% of, instead of 30, it's going to be 50. And that's going to be 20. Okay, well, if I add 2.4 and 20, okay, again, 2.4 is how much chlorine's in this one, and 20 is how much chlorine is in, wait a minute, that can't be 20. Yep, 40% of 50, that's 20. Okay, so that's 22.6. Now we're way off. Okay, so let's guess one more time. Okay, let's, apparently when I went lower on this one, I was even farther off. So let's do this. Let's go back up and make this one 60. Okay, and this one just 20. Okay, well, that's still 80 gallons, so we're good there. Now, instead of calculating 8% of 30 or 8% of 50 like we did before, now we're finding 8% of 60. Okay, well, that's 4.8. Okay, and over here, instead of calculating 40% of 30 or 40% of 50, we're calculating 40% of 20. Okay, well, that is 8. Okay, and when I add those together, I get 12.8. Well, we're closer. Okay, we're doing better anyway, but we're going to have to keep guessing, or we'll have to find a different technique. Okay, well, here's the technique I'd like to use. Instead of guessing and checking, which would get us the right answer eventually, what I'm going to do is say, hey, how about if I make a shortcut here? How about if instead of guessing another number, I'll just guess with a letter, A. Okay, so A gallons of the first one and B gallons of the second one. Okay, well, I still have to make sure that A plus B is 80. That's what we've been trying to make happen. So we'll write that down. A plus B has to be 80. Okay? And then the next thing is this. Instead of finding 8% of 50 or 8% of 60 or 30 or 8% of 60, we'll find 8% of A. So that's 0.08 times A. Okay? And instead of finding 40% of 30 or 50 or 20, we'll just find 40% of B. But we'll do it the same way. 0.4 times B. Okay? And when we added those together, the 8% of A and the 40% of B, what was I trying to get it to be? Well, 11.2. Okay? So now what I've got here is a system of equations, okay, that I need to solve for A and B, but I know how to do that. We've been doing that a while. So what I'm going to do is just make a copy of this and go work on it somewhere else. So let me make a copy. And we'll put that over on a new page. Okay. So now we're back to math that we've done before, and if you're new to this to these videos, if you don't know how to solve this system of equations, what I would do is pause the video and go look and find either one of my videos or somebody else's videos where they solve systems of equations by elimination. Okay, what we're going to do is say, look, I'd sure like to have these equations written so that the amount for A here and the amount for A there is the same, so that they cancel if I subtract, or the amount for B here is the same so that they cancel if I subtract. And the technique I think I'd like to use is this. I'm going to multiply the top equation by 4, and I'm going to multiply the bottom equation by 10. Well, how did I make that decision? Multiplying by 4 makes this into 4b. Multiplying by 10 makes this into 4b. Okay, so they'll cancel off when I subtract. So let's do that. We're going to multiply the top equation by 4, so 4a plus 4b equals 320. Notice I had to multiply everything by 4. And let's multiply the bottom equation by 10. So 0.8a plus 4b equals 112. So I got 0.8 because when I multiply 0.08 by 10, it becomes 0.8. Okay? So now we can subtract, and you'll notice what happens to the b's here. They cancel off, and I end up with 4 minus 0.8 is 3.2a. And over here, 320 minus 12 is 208. Okay? When I divide by 3.2, let's see what we get. So 208 divided by 3.2, I get 65. Okay? So apparently I need 65 gallons of A, and then since it needs to add up to 80, then 15 gallons of B. And now we've got our answer. Now we would have gotten that eventually if we guessed and checked, but this got us there quicker. All right, so that's the general overview about how to solve a system of equations. I'm sorry, how to solve a mixture problem using a system of equations.